Here three statements are given and we have to find which of them is true and which of them is false. Both telnet and email are reliable and connection oriented. Hence, statement 2 and 3 are true and ping is a connectionless. So, statement 1 is also true. So, here correct option is option A. A schedule is given and we have to find if it is conflict serializable or view serializable or both. If we draw the precedence graph for this schedule, we will be getting precedence graph as this one. Whenever there is a loop in the precedence graph, then that schedule is not conflict serializable. Here there is a loop between transactions T1 and T2. Hence, this given schedule is not conflict serializable. Let us check if the given schedule is view serializable or not. The given schedule is view serializable if there exists an equivalent serial schedule in which the initial read and final write operation of each and every data item should be same as in the given schedule, and also the read of each data item should be similar in the equivalent serial schedule. That means if T1 reads the data item written by T2, if T1 reads data item written by T2 in the given schedule, then in the equivalent serial schedule also T1 should read the data item written by T2. Then the given schedule is view serializable. If we observe the given schedule, here T1 reads the data item X initially. If we observe the given schedule, then the initial read operation on data item X is performed by transaction T1. So, in the equivalent serial schedule, T1 should read the data item written by, in the equivalent serial schedule, T1 should read the data item X initially. Here, the final write operation on the data item X is performed by transaction T3. In the equivalent serial schedule, same thing should happen. That means final write on X should be done by transaction T3. If we see the given schedule, here there are no other read operation except the initial read operation on X. So here one of the equivalent serial schedule is T1 followed by T2 followed by T4 followed by T3. Hence we can get an equivalent serial schedule in which the initial read operations and final write operations are same as in the given schedule. Hence we can say the given schedule is view serializable but not conflict serializable. So here the correct option would be option C. Here three properties are given and we have to find the properties which are ensured by two-phase locking protocol. In two-phase locking protocol, every transaction has to get the appropriate lock before accessing the data item. Hence, there might be a chance of getting deadlock. So, deadlock freedom is not guaranteed by two-phase locking protocol. the two-phase locking protocol allows schedules which suffer from cascading rollback. So we can eliminate this property. Two-phase locking protocol ensures serializability. So conflict serializability is ensured by two-phase locking protocol. So here the correct option would be option C, which states that two-phase locking protocol will ensure conflict serializability.
We want to execute 4 instructions with pipeline as follows. So there are 4 instructions, I1, I2, I3, I4, and assume that no measure is taken to handle hazards. So any pipeline hazards, no measure is taken to handle them. So there are 4 segments given, S1, S2, S3 and S4. So instruction I1 takes 1 cycle for segment S1, 2 cycles for S2, 1 cycle S3, 1 cycle S4. Like that, for the total instructions, the number of cycles required in each segment is given. So cycles required to execute the total instructions, these instructions with the pipeline is. So now, say for example, the clock cycles we write here. What you have to remember here is we have taken no measure for handling any types of hazards, whether there may be data hazards, control hazards, something like that. These are all called pipeline hazards. We have not taken any measure for that. So for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So these are the different types of clock cycles. Say for example, first instruction 1. How many segments are required? How many cycles for segment 1? 1 cycle. So just see the diagram. 2 cycles for segment 2, 1 cycle for segment 3, 1 cycle for segment 4. So now accordingly we'll execute. So S1 in the first clock cycle, S2 requires 2 clock cycles, S2 and S2, and S3 requires 1 clock cycle, S4 require 1 clock cycle. Instruction 1 is finished at 5th clock cycle. So parallelly in a pipeline, instructions 2 is also started. So we should not execute same segment at a time in a single clock. We have to go for next. So S1, it requires 2 clock cycles, S1 and S1, and S2 requires 1 cycle, S3 require 1 cycle, S4 require 2 cycles. So by 7th clock pulse, we have finished second instruction because 2 cycles are required for instruction 4. And then instruction 3, we have started with instruction 3 is segment 1 here because there is a stall here. We have to start here, segment 1. Next S2 requires 3 cycles, then S3 2 cycles, and S4 1 cycle. By 10th cycle, we have finished I3 instruction. Again I4 require 1 cycle for S1. We have to start at 5th cycle because S1 up to here it will be stall. So now S2 require 2 cycle, here also it will stall, S2 and S2, and S3 requires 2 cycles, S4 require 1 cycle. So exactly at 12th clock cycle it has been finished. So the total number of clock cycles required is 12. So option D is the correct option here.